Hello, dear students. Today, in a third lecture for Chapter 1, we're going to study Section 3, which is about the concentrations. In our prior lectures, we have talked about a lot of ideas about the solutions and the amount of solute in the solutions in terms of concentrated, diluted, saturated, supersaturated. But today we're going to make a mathematical calculation for the amount of solute in the solution in terms of the concentration. Okay, so there are two different pronunciations. There are two different ways. There are two different things to explaining the concentration in the solutions, and each of them separated from each other by a special characterization. Okay, first of all, as always, we have to explain the subject. Concentration is the measure of the amount of solute and given amount of the solvent or the solution. Why solvent and why or the solution? Why we've mentioned it two different things? Well, if the amount of solute, if we measure the amount of solute per the amount of solution, it will be a molarity, which is M capital with R molarity. But if we measure the amount of solute per amount of solvent, it will be molality, small m, molality with L, okay? So we have two terms of the concentration. When we refer the concentration, we have two terms, which are molarity and molality. Molarity is capital M, molality is a small m. Okay. What is the molarity? Molarity is the number of moles of solute. If the number is the number of mole of solute, okay, in 1 liter of the solution. In 1 liter of the solution. Molarity is the number of mole of the solute, okay, per 1 liter of the solution. So we can abbreviate as a molarity is equal to mole per liter. Liter for a solution, but mole, this is for solute. So for molarity, we're going to concern with the amount of solute and the volume of this overall solution. Okay. And also we know what is the number of moles. We have learned that in grade 11. Number of mole is equal to mass over molar mass. We know that. Mass in gram over molar mass, gram per mole. So we can calculate number of mole using this equation. Gram is the unit of mass, weight, okay? Gram per mole is the unit of molar mass. Also, we have some units for the volume except of the liter, because of we cannot run the equation of the molarity without using the liter, or we cannot run the equation of molarity with the unit of volume except of the solution. Okay? So the equation of molarity will be out of order if we don't have volume in the liter. Okay, we have centimeter cubic, milliliter, and liter as a units for volume, but which one is desired? The liter. Liter is desired. We know that, and we can make a conversion factor between milliliter to liter, centimeter to liter. So they are units of the volume. And as we know that, centimeter cubic is equal to milliliter. It means 1 centimeter cubic is equal to 1 milliliter. Okay. Now, let's talk about the conversion factors. Well, I will remind you how to convert milliliter to liter or liter to the other units. We know that 1 liter is equal to 1,000 milliliter, of course. So it will be 1 liter is equal to 1,000 centimeter cubic because of both have the same value, same thing, they are equal. And we know how to convert gram into kilogram or kilogram into gram. We know that 1 kilogram is equal to 1,000 grams. So if we convert gram into kilogram, we must divide by 1,000, and if we change kilogram to gram, we should multiply by 10 to the 3. I mean 10 power 3. This is by scientific notation. Well, let's solve some mathematical equation about the concentration. Okay. First of all, quickly I will solve this equation because of actually we will need that thing calculating molar mass in many questions. So we will do that one as the first and the last example about the calculating molar mass. Okay, calculate the molar mass of H2SO4, which is sulfuric acid. Calculate the molar mass of the sulfuric acid. How we can find out the molar mass? Hopefully you remember that. Molar mass of sulfuric acid is H2SO4. Okay, so let's find out the molar mass. Molar mass of sulfuric acid is equal to how many hydrogens do we get in 1 mole of the sulfuric acid? In 1 molecule of sulfuric acid, 2. So 2 times H, 2 times hydrogen, plus how many sulfur? Of course, 1 atom of the sulfur, 1 atom of sulfur. So 1 times sulfur plus 4 times oxygen. 4 times oxygen. Well, how we can get the atomic mass of the hydrogen, sulfur, and oxygen? So don't worry about that. It will be given from the question. The atomic mass of each the atoms should be given in the question. So because of actually it needs to be written in here, but you know, because of I prepared that notebook, so sometimes it will miss some information, but now we can add this information also. Hydrogen is equal to 1, the atomic mass, okay? And oxygen is equal to 16. Sulfur is equal to 35 gram per mole. Now substitute oxygen by 16, 4 times 16 plus. And replace sulfur by 32. Sorry, this is not 35. This is 32. It's not 35. 32. Sulfur is equal to 32. Okay. 1 times 32 plus hydrogen is 1. 2 times 1. 2 times 1. I think you don't need to use your calculator to find out this result because we know that immediately is equal to 98 grams per mole. This is the molar mass of the sulfuric acid. It's very easy, I know, and I'm sure that you can solve any question about the molar mass just like that. Multiply each numbers by the subscript number and then substitute each atoms by their atomic mass and then make a summation between them. Good. Another question. We have 0.4 grams of sodium hydroxide. 0.4 grams of sodium hydroxide. This is mass of sodium hydroxide, NaOH. Is dissolved in enough amount of water to make exactly 200 milliliters of the solution. So Look, this is volume, but in milliliter or liter? In milliliter. Look, we have mass. Mass is equal to 0.4 gram of NaOH. Mass of NaOH, sodium hydroxide. Very good. And the volume of the solution is equal to 200 milliliter. Calculate the molarity of the solution. What is the value of the molarity? It's very easy. Look, we have the equation of molarity. Molarity is equal to mole per liter. First of all, the volume is in milliliter. So we should convert milliliter into liter. How we can find out liter? Liter is equal to 200 milliliter divided by 1000 is equal to 0.2 liter. Okay, so it's about the volume. So we solved the problem about the volume. Now we have the volume in unit of liter. But, okay, we have liter. Now, what about mole? Oh, teacher, we don't have mole. So what do you have to do? Mole is equal to, we know that, mole is equal to mass over molar mass. Mass over molar mass. We have a mass of the solute, which is sodium hydroxide, 0.4 grams. And molar mass of sodium, we have to calculate molar mass of sodium hydroxide by ourselves. NaOH molar mass of NaOH is equal to 1 times Na plus 1 times O plus 1 times H. And substitute each atoms by their atomic mass, by their atomic weight. You will get molar mass of the sodium hydroxide is equal to 40 grams per mole. Oh my God, we don't have enough space. Well, I'll write in here. Molar mass is equal to let's write down in here. Molar mass of NaOH is equal to 40 grams per mole. Now we have molar mass and we have mass. Immediately we can find out the number of moles. So mole is equal to, well, I prefer to clean the screen, and now because of the idea is clear now, let's clean the screen and doing the solving method from the starting point. Okay. Mass is equal to 0.4. Volume is equal to 200 milliliter, and we converted milliliter to liter, and we saw that it's 0.2 liter. We converted that. Okay, very good. Molar mass of NaOH is equal to 40 grams per mole. We know where we get this number. We did the calculation. Okay, we have to find out the value of molarity. First of all, we should prepare number of mole. Mole is equal to mass over molar mass. Okay, is equal to mass is 0.4, molar mass is equal to 40. So number of moles is equal to mole is equal to 0.01 mole. Now we have number of mole and we have volume in liter. Immediately we can calculate the molarity. So molarity is equal to mole per liter. Look how it's easy. So molarity is equal to number of mole is 0.01 divided by 0.2 liter. So molarity is equal to, adding 1 0 to here, go 0, 0, 0.005 mole per liter. Very good. So now we have calculated the value of molarity very easily. This exactly has the same idea as the first question. So I think that's enough about the molarity. So let's talk about the molality. Small m. What is the molality? Molality is the second term of the concentration, referring about the concentration, or second expression of the concentration. Molarity is the number of moles of solute per 1 kilogram of the solvent. Oh, kilogram of the solvent instead of the volume of the solution. Now we have kilogram of the solvent. So molality is equal to mole per kilogram of the solvent. Oh, this is about the solvent, but molarity, capital M, is equal to mole divided by liter of the solution. It's for solution, but this is for solvent. Now that's the difference, because number of mole is always for the solute. Solute. We don't have any problem with the number of mole, so it's for the solute. But now in here, in molarity, we have a liter of a solution, but in molality we have a kilogram. So what's the idea? What's the deal? Why we have two different expressions for the concentration? Why? What's the difference between them? What is the benefit of them over each other? Okay, what are, or how we can find out the good point of each of them? Look, in here we have a kilogram, but in here we have a liter. Okay, let's talk about volume and kilogram. If we have something that has a volume of 1 liter, okay, in winter we know things can contract, so the volume will be decreased, and in the summer the volume can expand, so the volume will be increased. What will happen? In the winter, volume changes, decreases. In the summer, volume changes and increases. What will happen with the value of the molarity? It stays constant or changes by changing the temperature and, or even about the pressure. If we increase the pressure of anything, the volume can change. So what will happen about different measurements of the molarity at different temperature, at different pressure? Of course, the value will be changed. That's why, that's the disadvantage of the molarity. Because of the value of the molarity is not constant at different temperature and pressure. Okay? But what about the molality? In the molality we have a kilogram. 1 kilogram is 1 kilogram. At winter, at summer is 1 kilogram. It cannot be changed. Increase pressure, decrease pressure, 1 kilogram is 1 kilogram. Never change. So it can stay constant at the wide range of the temperature and the volume. So which of these expressions is the best to be used when we have changed temperature and pressure? Of course, molality. Why? Because molality can stay constant due to this kilogram, but molarity can be changed because of, in here, the volume. We have a volume from the bottom of the fraction. That's why when we should use molality, what's the condition of the molarity when we talk about a vapor pressure and temperature? We should use the molality because of molarity can change. That's why it's not good. That's the difference between them, and this is the advantage of molality over the molarity. Concentration are expressed as a molality when studying properties of the solution related to the vapor pressure and temperature. Did you remember what I told you? Because it does not change with changing the temperature, but molarity can get changed when we change the temperature. Okay. Now we have a question about the molality. Calculate the molality of a solution contains 0.01 mole of HNO3 in 400 grams of water. Now we have number of moles of solute, we have number of moles of the solute, and gram mass or mass of the solvent. Did you remember the equation of the molarity? Molarity is equal to mole of solute per kilogram of the solvent. Now, look, molality is equal to mole of solute per kilogram of the solvent. Per kilogram of the solvent. Good. We have number of moles, but we don't have a kilogram. We have a gram. Look, always the information, the given information about the solute should be in the number of moles. Okay? And for the solvent, we should convert the information into kilogram. If it's not kilogram, of course. Now it's gram, so we should convert into kilogram. How we can convert 400 grams into kilogram? It's very easy. Just divide it by 1,000. We can turn this 400 gram into kilogram. So mass of the solvent, is equal to 400 divided by 1,000 is equal to 0.4 kilogram. Now immediately we can find out the value of the molality. Molality is equal to mole per kilogram, mole of solute per kilogram of the solvent, and is equal to 0.01 divided by 0.4 kilogram. Look, about the molality questions, you don't have anything to do without identifying solvent and solute as a first step. So, this is about the molality. So now, let's identify the solvent and solute. Then you can start to the solving. Okay, HNO3 in water, this is solute. In water, water is a solvent. So, we should have the information about the solute in number of moles, and for solvent in kilogram. This is mole, this is gram. We just convert gram into kilogram. Now it is equal to 0.025 molal. So that's the molality of this solution. Let's solve the last question about the molality. This is very good example. Okay? I love this question because we only have two masses, and we should decide which of them is the solvent, which of them is a solute. For that purpose, we should make a review for some information that we learned in a prior lecture, first lecture, about how to identify solvent and solute. Okay. We have ethylene glycol, which has a mass of 6.5 kilograms with 1.5 kilograms of water. Now each of them are liquid, and we don't have that form of phrase. Glycol in water, water in glycol. So how we can recognize the larger amount is a solvent, and the smaller is a solute. So we should keep this information in by kilogram. Well, we don't have any problem with that, but we should convert this kilogram into number of moles. So first of all, in number of moles, we use it kilogram or gram. Of course, gram. So the first thing, we have to convert mass of water is equal to 1.5 kilogram, and it's equal to 1,500 grams. well, just multiply it by 1,000, you will get 1,500 grams. Then, how we can find out the molality? Molality is equal to mole per kilogram. We have a kilogram of solvent, but we don't have number of mole. Okay, it's very easy. Mole is equal to mass over molar mass. We have a mass 1,500 grams, but how we can calculate molar mass? Okay, it's very easy, because we know that molar mass of H2O is equal to 2 times hydrogen plus 1 times oxygen, and this is equal to 18 grams per mole. Now we get the value of molar mass, so let's find out the value of number of moles. Okay, mole is equal to, why we calculate molar mass for water instead of ethylene glycol? Why? Okay, we calculate molar mass to find out the value of number of moles, the value of moles. So moles, it's for solid or solvent. For solid, which of them is a solid? Water. That's why we calculated molar mass for the water. Now mole is equal to mass over molar mass. We have mass 1,500 grams over 18. Okay? Now we can find out the mole of water, which is equal to 83.33 moles. Oh, now we have number of moles. So the last step, let's find out the value of the molality. Molality is equal to mole per kilogram. This is number of mole. 83.33 dividing by 6.5 kilogram. You see how it's easy? It's just like drinking a cup of water. Okay? I think it's very easy. The only thing you have to memorize all the notifications. So the last answer is equal to 12.82 molar or mole per kilogram. That's the units of molarity. Okay? It's very easy. We have 2 kilograms. We just converted a kilogram about the solid into number of grams, and we did the other steps. The only difference between this question and the other questions is that in this question we need some further steps. بەم شێوەیە کۆتایی بەوانەی ئەمڕۆمان دێنین کە کۆتاوانە بوو لە بابەتی بەندی یەکەم. هیوادارم سوتان لێبینی بێ تا بەندی دووەم بەخواتان دەست پێرم هەر شاد و سەرفراز بن. خواتان لەگەڵ.